Good day, my friends. Let's learn something new today.
Have you ever shared a pizza with a friend? It's a common experience and it can be a lot of fun. But have you ever thought about the math behind it? Maybe you cut it in half. This is a simple way to share, ensuring that each person gets an equal portion. Or maybe you needed to divide it into more slices, so everyone gets a piece. The more friends you have, the more slices you need. When you divide something into equal parts, you are using fractions. Fractions help us understand how to share things fairly. And guess what? Fractions are examples of rational numbers. Rational numbers are all around us, even in our everyday activities. A rational number is any number we can write as a fraction. This means it can be expressed as the ratio of two integers. The top number is the numerator. It tells us how many parts we have. For example, in the fraction 3/4, the numerator is 3. The bottom number is the denominator. It tells us how many parts make up the whole. In the fraction 3/4, the denominator is 4. Here are some examples of rational numbers. Rational numbers can be simple or complex, but they all follow the same basic rules. 1/2. This means we have 1 out of 2 equal parts. It's a very common fraction that we see in many situations. 3/4. This means we have 3 out of 4 equal parts. This fraction is often used in recipes and measurements. 5/1. This means we have 5 whole parts. When the denominator is 1, the fraction represents a whole number. Yes, whole numbers are rational too. Any whole number can be written as a fraction with a denominator of 1. Rational numbers can be positive or negative. This means they can represent gains or losses, profits or debts. They can also be decimals, as long as the decimal either ends or repeats in a pattern. For example, 0.75 is a rational number because it can be written as 3/4. For example, 0.5 is a rational number because it's the same as 1/2. Understanding rational numbers helps us in many areas of life, from cooking to budgeting. Rational numbers are everywhere. They help us make sense of the world by allowing us to divide, share, and measure things accurately. So next time you share a pizza, remember, you're using rational numbers. Let's head to the kitchen. Rational numbers are everywhere when we cook or bake. Recipes use fractions to tell us exactly how much of each ingredient to use. Imagine you're making cookies. The recipe might call for 1/2 cup of butter, 1/4 cup of sugar, 3/4 cup of flour. See those fractions? They are rational numbers helping us measure the right amount. Without rational numbers, our cookies might turn out too buttery, too sweet, or not sweet enough. Next stop, the store. Rational numbers are important when we're dealing with money. Think about prices, discounts, and how much things cost. Let's say you see a cool toy on sale for 25% off. That percentage is a rational number. It means 25 out of every 100 cents are taken off the original price. When you pay for the toy, you might use dollars and cents. Cents are fractions of a dollar. For example, 1 cent is the same as 1/100th of a dollar. Rational numbers are also our friends when we need to measure something. We use them for length, weight, volume, and more. Imagine you're building a birdhouse. You might need to measure pieces of wood that are 1 1/2 inches long, 6 1/4 inches wide, 4 3/8 inches tall. Those fractions help us make sure the birdhouse is the perfect size for our feathered friends. Section 5. Rational numbers and time. Tick-tock, tick-tock. Rational numbers help us tell time too. We divide hours into quarters and halves. We talk about minutes and seconds as fractions of an hour. For example, 15 minutes is 1/4 of an hour, 30 minutes is 1/2 of an hour, and 45 minutes is 3/4 of an hour. Without rational numbers, it would be much harder to talk about time accurately. Section 6. What about irrational numbers? So far, we've learned that rational numbers can be written as fractions. These fractions represent parts of a whole and can be expressed as a ratio of two integers. For example, 1/2, 3/4, and 5/8 are all rational numbers. They have a clear, repeating pattern in their decimal form, making them predictable and easy to work with. But there's another type of number out there: irrational numbers. These numbers are quite fascinating because they defy the neat and tidy world of fractions. Unlike rational numbers, irrational numbers cannot be written as a simple fraction. They are the rebels of the number world, breaking the rules and challenging our understanding of mathematics. Irrational numbers are numbers that cannot be written as fractions. This means that their decimal representations are non-terminating and non-repeating. They go on forever without settling into a predictable pattern. This makes them both intriguing and complex as they cannot be precisely captured by a simple ratio of two integers. Their decimal representations go on forever without repeating in a pattern. This infinite, non-repeating nature is what sets irrational numbers apart from their rational counterparts. It also makes them incredibly useful in various fields of science and engineering, where precise calculations are often required. One famous example is pi. Pi is a mathematical constant that represents the ratio of a circle's circumference to its diameter. It is an irrational number, meaning its decimal representation goes on forever without repeating. This makes pi an essential tool in geometry, trigonometry, and calculus. Pi is the ratio of a circle's circumference, the distance around the circle, to its diameter, the distance across the circle. This ratio is constant for all circles, making pi a universal constant. Despite its infinite decimal expansion, we often approximate pi as 3.14 for simplicity in calculations. We often approximate pi as 3.14, but its decimal representation goes on forever. This endless sequence of digits has fascinated mathematicians for centuries, leading to numerous attempts to calculate pi to as many decimal places as possible. Today, with the help of computers, we have calculated pi to trillions of digits. Another example is the square root of 2, which is approximately 1.41421356. The square root of 2 is the length of the diagonal of a square with side length 1. Like pi, its decimal representation is infinite and non-repeating, making it another classic example of an irrational number. The decimals keep going and going. This infinite nature of irrational numbers makes them a fascinating subject of study in mathematics. They appear in various mathematical contexts and have practical applications in fields ranging from physics to computer science. Understanding irrational numbers helps us appreciate the complexity and beauty of the mathematical world. Section 7. Rational versus irrational, a number line showdown. Imagine a number line stretching out infinitely in both directions. We can place all the rational numbers on this number line. Each rational number has a specific point. For example, 1/2 goes right in the middle of 0 and 1. Now, here's the thing about irrational numbers. They fill in all the gaps between the rational numbers. Even though we can't write them as fractions, they still have a place on the number line. Section 8. Math with rational numbers. In this section, we will explore the fascinating world of rational numbers and how we can perform various mathematical operations with them. Rational numbers are numbers that can be expressed as a fraction, where both the numerator and the denominator are integers. They are an essential part of mathematics and are used in many real-life applications. Just like we can do math with whole numbers, we can also do math with rational numbers. This includes addition, subtraction, multiplication, and division. Each of these operations has specific rules that we need to follow to get the correct result. Let's start by looking at addition. Addition. To add fractions, we need a common denominator. This means that the bottom numbers of the fractions must be the same. Once we have a common denominator, we can simply add the numerators together and keep the denominator the same. For example, to add 1/4 and 1/4, we get 2/4, which can be simplified to 1/2. That means the bottom numbers of the fractions must be the same. If the denominators are not the same, we need to find a common denominator by finding the least common multiple of the two denominators. This step is crucial for accurate addition of fractions. Subtraction. Subtracting fractions also requires a common denominator. Just like with addition, we need to make sure the denominators are the same before we subtract the numerators. For example, to subtract 3/8 from 5/8, we subtract the numerators to get 2/8, which simplifies to 1/4. Multiplication. To multiply fractions, we multiply the numerators and the denominators. This is a straightforward process. For example, to multiply 2/3 by 3/4, we multiply the numerators, 2 and 3, to get 6, and the denominators, 3 and 4, to get 12, resulting in 6/12, which simplifies to 1/2. Division. Dividing by a fraction is the same as multiplying by its inverse. The inverse of a fraction is created by flipping the numerator and the denominator. For example, the inverse of 2/3 is 3/2. To divide 4/5 by 2/3, we multiply 4/5 by the inverse of 2/3, which is 3/2, resulting in 4/5 asterisk 3/2 equals sign 12/10, which simplifies to 6/5 or 1 and 1/5. To find the inverse, we simply flip the numerator and denominator. This step is essential for performing division with fractions accurately. Understanding how to find and use the inverse of a fraction is a key skill in working with rational numbers. These operations might seem a little tricky at first, but with practice, they become second nature. Practicing these operations regularly will help you become more comfortable and confident in working with rational numbers. Remember, math is a skill that improves with practice, so keep working on those problems and soon you'll be a pro at handling rational numbers. Section 9. Rational numbers. Important and useful. Rational numbers are everywhere in our world. We use them when we cook, shop, measure, tell time, and so much more. Understanding rational numbers helps us make sense of the world around us. And while irrational numbers might seem a little mysterious, they play an important role too. Together, rational and irrational numbers make up the set of all real numbers, which is the foundation of mathematics. So keep exploring the world of numbers and remember, math is everywhere.